this video, you'll be watching an excerpt from our Civil 3D intro class. I'll be going over the basics of how to create a surface in Civil 3D. Creating surfaces. So we'll be creating surfaces today, tomorrow, and on day 3, but in different ways. So today, we're going to create a surface from these points. So it'll be an existing ground surface. Surfaces are covered on page 70 of the book. They are a 3D geometric representation of an area of land. Why do we use them? They model topography of existing ground and finished ground. Also, pretty much all the data that you need to show on your plans will come from the surface. The surface has contour lines, contour labels, slope labels, spot elevation labels, right? All these things need to show up on your plan set. So all that data is stored inside of the surface. How do we create the surface? From the Prospector tab of Toolspace, we can right-click on Surface and click Create. So there's a couple of ways to do it. I'll point out the different ways. And then this is just a little side note. Common definition data includes point groups, contours, break lines, 3D faces. So we'll go over what to do with our surface. My coworker created this slide here. So he says, a surface is built with triangles that connect points. The triangles are like tiles. Note the tiles can be angled or tilted when points have different elevations. And so imagine every corner of these triangles has a point with an elevation, and then these lines, the edges or the sides of the triangles connect those points, and then the face of that triangle is a 3D face of your surface. And this is a slide that I created. This is like the general steps in creating a surface. So number 1, you create a surface. This can be done through Toolspace or the ribbon. When you create a surface, you're just giving it a name and a style. That's pretty much it. 2, we're going to add data to that surface through the surface definition. Some things that we're going to add is we're going to add point groups and we're going to add break lines. Step 3, you want to add a boundary to your surface. This will cut off any extra surface that shouldn't be there. And I said, you just draw a 2D polyline around the edge of the surface and add that to your surface definition. And then 4 is optional. Sometimes you may think your surface is not smooth enough. You can use the smooth surface option, or you can apply a contour smoothing option. So smoothing the surface is considered a surface edit, and it actually affects the definition of your surface. It's going to change the elevations of your surface slightly. Using the contour smoothing does not change the definition of your surface, does not change any elevations. It is just a style setting where you make the contours look more smooth and curved rather than sharp. So we will go through all of this. Let me copy. All right. So let's get started on our surface. So right now we just have model space with points. That's pretty much all we have, right? Save what you have. Go to the Prospector tab of Toolspace. In the Prospector tab, we have all these categories. Surface is one of the categories. So option number 1, you can right-click on surface to create surface. This is typically what I do. Another option, in the home tab of the ribbon, we have all of the Civil 3D creation tools. Surface is one of those buttons. And here you can also create surface. All right, so I like Toolspace. I'm going to right-click in Toolspace to create my surface. Here, the 2 things that we need to do are give it a name and assign it a style. So for the name, let's call this eTopo. So existing topography. For the style, 2 and 10 background is fine. Description is optional. Render material is optional. So just again, 2 things, name and style. Click OK. All right, nothing really happens in model space, but if you look at Toolspace, surface now has a plus on the left. Click the plus. eTopo is there, click the plus. Definition is here, click the plus. And these are all these empty categories that we can use to build the definition of that surface. So you have to just think, what do I actually have? What kind of data, what kind of information do I have? I have points, right? So looking through the definition options here, there's point file. This allows me to go grab the text file, but I've already done that. I already brought the points into the drawing. The second one is point groups. So I do have point groups. Let's use that. Let's right click on point groups and add. In the list, I want to be very specific. I don't want to add all points because if I bring in additional points next week or tomorrow, they will automatically go to the all points group and they will automatically be added to the eTopo surface. So do not use this one. I want survey. Survey is all the points that I need right now. So selecting survey, clicking OK. All right. You should already see some contour lines, right? The surface now has data, so it's able to generate those contour lines. Point groups has a dot in front of it. That dot means we've added a point group. When point groups is selected up here, down below, it shows you the name of that point group. If you messed up, you can always right click on the name and delete it from the definition. So we want to keep it, it's good. So we've done step number 2, the first half, and there's a second half, but let's take a look at the surface first. CAD Masters offers online and classroom training for a variety of Autodesk software. For more information, go to www.cadmasters.com or give us a call at 925-939-1378. Click on your surface, right click, and open Object Viewer. In Object Viewer, use your left mouse button, click and drag, take a look at the surface. If you want to look at the triangulation, you can kind of see it already, but in the upper left, you can switch it over to shaded with edges. And so there you can see all the triangulation. Basically, it connects the points and it picks the shortest distance between points to connect. So I definitely see the top and toe right here. It's like a little cliff. You have top and toe. The ridge, I can kind of make it out down the middle here. And then I want to point out an area that is not correct. Over on this side, see how these triangles are really large? There's actually no points in this area. It's connecting from the point here all the way across to the point here. And so it's creating this flat area that really is not accurate. So one of the things we need to do is add a boundary to cut off the outer edge and cut off this portion. I'll go back to shades of gray. And then I will escape out of here. Questions? So there are surface edits, which I call a quick fix. And then there are long-term objects that should be added to your surface definition. Let me see if I have a slide. Yes, I do. Okay. So in the ribbon, when you select your surface and go to the ribbon, there is an edit surface button, which is right here. And there's a long list of things you can use. So there's add line, delete line, swap edge, add point, delete point, modify point, and so on. Right now, I want to go over 2 of those, swap edge and delete line. So again, these quick surface edits are a good short-term solution, but they are not a good long-term solution, and I'll discuss that. So let's take a look. In order to edit the surface, I need to be able to see the triangulation. Right now, we're looking at contours. So what I want us to do is select the surface, right-click, And let's go to surface properties. In the first tab, we see our style is 2 and 10 background. Use the drop down. We're looking for contours and triangles. I do want to see the triangles so that I can make some edits, but I don't want to see contours. So what I'll do is I will copy my current selection. On the first tab, I want to change the name. I want it to just be triangles. The description, I just want that to be triangles as well. And the name, if you want to put your initials, you can. Okay, so now we need to make the real changes. On the display tab, there are different view directions at the top left. So plan view is just 2D top view. Model is 3D when you go into object viewer. And then there's also section. So right now we're just worrying about the plan view. Right now we see triangles are on, borders on, contours are on. So turn off the contours. I only want triangle and border. All right, so the triangle style will show triangles. Click OK. Here's that new style. Click OK. And this is what we should see. Right? You cannot edit what you cannot see. And so we want to play with the triangulation. So we need to be able to see that triangulation. All right. So let me point out a couple of things. Maybe the easy one first. I discussed how this area should not exist. There are no points. And so we don't want the triangulation to go out that far. We can delete these lines. Select your surface. And then up in the ribbon, look for Edit Surface. And we're going to use delete line. All right, once you selected delete line, we're going to just select the lines that we don't think should be here. You can use your own judgment. Once you've selected those lines, hit enter. Notice the boundary, the green line, shrinks back to meet up with that triangulation that we kept. So that was quick and easy. It's a nice way to get rid of that portion of the surface. But if you're working on this project for several weeks, several months, and you're continuing to add definition to this object, when you rebuild the surface, this triangulation could come back. And so that's why we recommend not to just delete lines, but to add an actual 3D polyline around the outer edge to cut off the surface. Right? As you're working on this surface, you can always right-click on the name of the surface in Toolspace and rebuild. And so as you rebuild with each change, again, that triangulation could come back. But if you have a deadline's today, you just need to get it done. Go ahead, delete lines, submit, and you're all good, right? Okay, let's isolate the ridge points. So still in Prospector tab of Toolspace, point groups, right-click on point groups, properties. Let's move ridge to the top and hide points to the second position from the top. So we have ridge and then hide points. Click OK. So that should isolate those ridge points so they're easier for us to see. And then I want to point something out. So I'm going to zoom in to this right side. The ridge is like the top of the hill, and I want it to be a nice consistent line across the top of the hill. So I have a triangle line that connects from point to point to point to point. But in this location, we don't have a line going from this ridge point to this ridge point. by default, it connects the shortest distance between points. So to force this line to go the opposite direction, I can select the surface, go to edit surface, and use swap edge. So this will flip the line to go the other direction. I'm going to try it out. Swap edge, select the line, and it swaps to the other way. Okay, so if you haven't done it yet, do that. And then we have one more location over here where we have the triangulation going the wrong way. So again, I'll select my surface, go to edit surface, swap edge. Click the two lines that need to be fixed. And now I have a line connecting the ridge points. So just like I mentioned with this portion, as you continue adding to the definition of the surface and you rebuild the surface, those triangles may swap back to where they originally were. And so this is a quick fix, but it's not a good long-term solution. Even if I look at Object Viewer, I was trying to make the ridge a nice consistent line across the top. There is that line across the top, but it's not smooth, right? It dips down in certain locations. So swap edge works, but it doesn't really make it any smoother. Let me escape out of here. So if we did create some edits and we want to remove those edits, we can do that through tool space. So I have my surface, eTopo. Here's my definition. Under the definition, we see that we've added a point group. That's good. And we see that there are some edits. So the dot in front of edits lets me know there are edits. Down below, it lists out each edit. So I have delete lines, swap edge 3 times. If I want to get rid of one of them, I can just right click and delete. But if there's a bunch of things that I want to remove, another option is go into the eTopo surface properties. So do this one with me. Inside of the surface properties, there is a definition tab. At the bottom half of that tab, you can see all of our steps. So point group, delete line, swap edge. If you want to just temporarily remove a step, you can uncheck that step. But if you want to permanently remove it, you can select delete lines, hold shift, select the last swap edge. All of them will be highlighted. Then you can right click in the blue and remove that from definition. So it's permanently deleting it. It's asking, do you want to permanently remove? Yes. All we have left is point group. Click OK. Rebuild. And so we're back to where we started with these triangle lines and these triangle lines here and here in the ridge. Okay, so now let's talk about the correct way to do this. It's still in the chat, but I'll bring it up here. CAD Masters offers online and classroom training for a variety of Autodesk software. For more information, go to www.cadmasters.com or give us a call at 925-939-1378. So adding data, we added a point group. Another thing that most surfaces need is breaklines. Breaklines will hold a consistent slope across several points. So let's say I have a road design. The center line of the road should have a breakline. The edge of pavement should have a breakline. The flow line of the gutter should have a breakline. Top of curb should have a breakline. Back of sidewalk should have a breakline, right? So wherever you need like a nice, smooth, consistent slope, you want to draw a breakline connecting those areas, connecting those points. So for us, we have a very, very basic surface. We have ridge, top, and toe. Let's go back to point groups, point group properties. Let's move toe to the top and top to the top. So we have top, toe, ridge, and then hide everything else. Click OK. So you'll see just those points. If your surface looks like it's on top of the points, you can select the surface, right click, display order, and send it to the back. Okay, so now the points are on top of the surface. I'm going to save that. So I just want a break line connecting the ridge points, and then two more, one connecting top, one connecting toe. So it'll hold a nice consistent slope across those areas. To do that, let me bring up another slide. We are going to create what we call a break line. A break line breaks the triangulation. So for example, right here, if I draw a break line from this ridge point to this ridge point, it's breaking these triangles. It will not allow it to triangulate across the break line. It will force it to triangulate on either side of the break line. A break line can be a 2D polyline. 2D polyline has lines, has arcs, but the downside is it only has a single elevation. So in our case, we should not use a 2D polyline. We have multiple elevations. A break line can be a 3D polyline. Downside of a 3D polyline is you cannot have any arcs. You're connecting the points with straight lines, but it picks up every elevation. And then the third one is feature line. We will go over feature lines on day 3. Feature lines are very useful in Civil 3D. It has lines, it has arcs, it has varied elevations, and it has the option to use grading tools. So on day 3, we discuss grading, and we'll go over a bunch of things that use feature lines. Okay, so for today, we don't want to get into feature lines yet. We're going to connect the points using a 3D polyline, and that should work out just fine. So the shortcut for a 3D polyline is 3P. So in my drawing, I want to turn on the snap called node. That will allow me to pick up each elevation as I click on the point. And again, I'm using a 3D polyline, 3P, enter. I'm going to snap connecting the ridge points in order. In a real project, you probably would put these on their own layer. So it could be a layer called break lines. It could be a layer called ridge. Just depends. Are you going to print it? Are you going to freeze it? Once you've connected all those ridge points, we can now add this break line to the surface definition. So over in tool space, under surface eTopo definition, there's a category for break lines. Okay, so we're going to right click on break lines, and we're going to add. For the description, it's optional, but we can type ridge. For the type, I always use standard. Standard uses the elevations that I've already snapped to. If I were to pick something else in this list, it's going to make some interpolations between points. So don't do that, just go with standard. Weeding factor. If you have too many vertices on your polyline, you can weed out some of the vertices. In our case, we don't need to do that. Supplementing factors is if you want to add additional vertices. So the more vertices you have along the break line, the more triangles you're going to get. The more triangles you get, the smoother the surface will be. So I typically do add supplementing factors. My default is always 10 feet apart. And then mid-ordinate distance is only along curves. We don't have curves on this break line, so this number doesn't really matter for this particular example. However, I want you guys to get in a good habit of using a small number. I use 0.01, and then I will explain what that means. So supplementing factors will add additional vertices along your break line. We said to add a vertice every 10 feet along our break lines. Mid-ordinate distance we'll add additional vertices along a curve. So for example, if we have this curve, the curve only has two vertices, one at the start, one at the end. When you create a surface, it triangulates. There are no curves, there are only triangles. So when it triangulates, it connects from this endpoint to this endpoint. You completely lose the curve. The mid-ordinate distance is the distance from the midpoint of the curve to that triangle line. So what we're doing is we're saying if this distance is greater than 0.01, add in another vertex right here. So if once you add that vertex, it triangulates from here to here to here, it measures the new distance between the curve and the line. If that new distance is still greater than 0.01, it adds another vertex at that midpoint, and so on until that D value is less than or equal to 0.01, right? So basically, by putting in a small number, you're adding a lot of vertices along the curve. You're keeping the triangulation close to the curve. So even if it's not a real curve, it will look curved from a distance. Okay. All right. So using this number is a good habit. Click OK. Select the break line. Enter. So you'll see every 10 feet, we have these additional vertices, which creates these additional triangles. In this example, it doesn't make it much smoother, but if you want to look at Object Viewer, you can take a look. And in general, adding those vertices should make it smoother along those break lines. All right, so I want you guys to draw 3D polyline connecting the top points, 3D polyline connecting the toe points, and then I want you to add them as break lines to your surface. Then you can chat them. You can also add them both at the same time if you want. So we've added those break lines. So again, you would add these at critical areas such as center line, top of curve, flow line, those types of things. So we've added break lines here. Again, if you mess up, you can always right click and delete it from the definition, but we've had them there. Then the next step, let me bring up my PowerPoint again. CAD Masters offers online and classroom training for a variety of Autodesk software. For more information, go to www.cadmasters.com or give us a call at 925-939-1378. Back to this slide. So we've added data to our surface definition. Step 3 is adding a boundary. We want to cut off that extra part of the surface. So to do that, we're going to draw a closed 2D polyline around the edge of our surface. So here, I'm just going to use, actually, let me turn on all the points first. So go to point groups, properties, use survey, bring it to the top. Now that I can see all the points, I know where I do not have data, right? And you can watch me first. I'm going to use polyline. The east side is fine. The north side is fine. The west side is fine. The only place where I have an issue is on the south side. So on the south side, I want to make sure I'm using that node snap. And I'm going to snap to each point along that end. Again, you can put this on another layer, such as border or boundary. That way you can hide it by freezing it. So here, I don't want to just snap to that endpoint, I want to go to the command line and use close. You must have a closed polyline for your boundary. If you forget to close it, which sometimes we do, you can always select the polyline at the end, open up regular properties, and at the bottom of properties, it'll say closed, yes or no. If it says no, then you just switch it to yes. It'll force it to close. Okay. All right, so now that we have drawn this 2D polyline, we can go over to our eTopo definition and add it right here as a boundary. So we'll right click on boundaries, add. For the name, we're going to just call it outer boundary. There are actually 4 different types of boundaries. Today, we're only covering outer boundary, but tomorrow we'll cover the other 3. So selecting outer. And then there's 2 options right here. There's a check in front of non-destructive break line, or your other option is to not have it checked. So let me explain the difference. Okay. So if you check the box, it's non-destructive break line, it will triangulate your surface first, and then it will cut off your surface at the boundary line. So it's triangulate first, cut at the boundary line second. If you do not check this box, it's considered destructive. So destructive will destroy any triangles that may pass through this boundary line. So you'll notice there are no triangles that pass through the boundary line. Your triangulation will stop at the last piece of information inside the boundary. Makes sense? Any questions? Okay, so in our example, I've snapped to these points. So I don't want the boundary to eliminate those points. I want to keep those points. So I'm going to use non-destructive. So I want to have it triangulate first and cut at the line second. So using non-destructive. Mid-ordinate distance, again, is along the curves. We don't have any curves, so it's not too important, but just, again, good habit, 0.01 for mid-ordinate distance. Click OK. All right, and now select the polyline that we drew, and it should cut off that piece of the surface. So reiterating why we want to do this instead of deleting triangle lines. Okay, Civil 3D is a great program. However, sometimes it crashes. And if it crashes and you lose the surface, you typically don't lose these objects. Like you're still going to have points. You're still going to have this polyline. You're still going to have these 3D polylines. So if you mess up or the program messes up, it's real easy to quickly recreate the surface, add the boundary, add the break lines, add the point group, and then you're back to where you were before the crash, right? If you don't have these physical objects in here, the edits will not be saved. So there's no way to get those edits back other than manually creating those edits again, right? So you want to keep solid objects like polylines, 3D polylines, points in your drawing. Use those as part of your surface definition. All right, so I'm saving that. Let's see what else we need to do here. So we have our data, we have our boundary, and so we're on the last step of smoothing out the surface. Let's take a look at the surface in Object Viewer. Click on your surface, right click, go to Object Viewer. In Object Viewer, use your left mouse button to click and drag. And you'll see it doesn't look terrible, but it still has large triangulation. You can see the large triangulation. Okay. So I want smaller triangles so that it can look smoother. So we have 2 choices. We can smooth through the surface definition. That will modify the elevation slightly. Or we can just smooth the contour lines so that the contours look good. Since we're not going to submit the 3D model, we're going to submit the 2D plans, right? Maybe we only care what the contours look like. So I'll show you both just so you have both options. So to modify the definition, adding more triangles, what we can do is select a surface. One option is in the edit surface drop down. We have smooth surface right here. I'm wondering if we also have it in the right click. Let's see, maybe not. No, it's not in the right click. So it's definitely in the ribbon, smooth surface. Or if you go to tool space, edits, you can right click on edits, and you also have all those editing tools. So smooth surface is right here. So either method, pick smooth surface. This window is going to pop up, and the selection method for or smoothing method is going to be natural neighbor interpolation. So what it's going to do is it's going to take our existing points and it's going to interpolate additional points between them. And it's going to triangulate between those brand new points. Then under point interpolation, extrapolation, output. Output locations is grid based. That's what I typically use. It's going to draw like a grid across the surface. Every grid square will be split into 2 triangles. And then those triangles will be used for smoothing out our surface. Select output region is 0. 0 just means nothing is selected. So if you click on 0, there's a button on the right, click that button. The command line gives us some options. We can smooth a rectangular portion of the surface, a polygonal portion of the surface, or the entire surface. So if you have a very large surface, I don't recommend smoothing the entire surface. The more triangles you add, the slower your drawing is going to be. But we have a very small surface here, so I'll do the whole surface. It puts a 1 in that box. It just means now something has been selected. Grid X spacing and grid Y spacing. So how often in the X direction would I like an additional point? I'm going to say every 10 feet. And then in the Y direction, same, I want a new point every 10 feet. Grid orientation, I'm just going to have it do vertical lines, horizontal lines to create the grid. If, again, your project is going diagonal across the screen, you may use this option and use the button to draw a line across following your project. Or you could type 45 degrees, whatever angle you want the grid to use. Okay. Down below, number of output points. This is how many additional points it's going to add to the surface. So 4,333 is fine. If your number down here gets larger than like 10,000, it is possible it's going to slow down a little bit, but you do what you got to do, right? Click OK. All right, there it is. So every 10 feet, it's created these like grid lines, and each grid square is split into a triangle. And these are additional points that are helping smooth out the surface. There are some weird ones like that, right? So that's a real point, and it's making sure that it is triangulating to that real point. But if there are no real points, it has these perfect triangles. So let's take a look in Object Viewer. Select your surface, right click, Object Viewer. Okay. In Object Viewer, rotate it, and you'll see it's much smoother. Yes, you see little sharp points around there, but you're not going to see that in a plan view in a 2D drawing. You only see that in 3D. The ridge line is very well defined. The top and toe is very well defined. I want to demonstrate what would happen if you did not have break lines at the ridge, the top, and the toe. So just watch. So let's say I go into my surface properties, my definition tab, and I'm temporarily removing the break lines. So they are unchecked. Rebuild. And it's difficult to see from 2D, but if I go back into Object Viewer, you'll see that ridge completely smooths over, and you see the top and toe has been smoothed over. Okay, so specifically when you use smooth surface, you want to make sure you have break lines at those important locations. And we still have top and toe, but it doesn't know to hold the line all the way across the top and hold the line all the way across the bottom. So it just smooths across this way. Okay, so I'm going to get rid of that. I'm going to go back to my surface properties, bring those break lines back, rebuild. And now I should be back to where you are. There it is. So that looks pretty good. Let's go back into model space and let's turn on the contour lines. Pick your surface, right click, surface properties. And then we want to, sorry, I forgot what I was doing. Oh yeah, on the information tab, we don't want to see triangles. We want to see contours. So let's pick 1 and 5 background. Click OK. All right. So overall, the contours look pretty good, pretty smooth, but I want to point out some areas down here on the south end. If you zoom in, you'll see that there are still some sharp contours, some sharp corners. So I don't want to smooth the surface anymore. I don't want to change the elevations anymore, but I want to smooth out these little pointy areas. So I can do that through the surface style. Let's select the surface, right click, and this time we're using edit surface style. I want to keep my current style, but make it a little smoother. So edit surface style. All right, so this is the contours 1 and 5 background style. There is a contours tab. On the contours tab, right here, we have contour smoothing. So if you click the plus, you see contour smoothing is set to false. We're going to switch it to true. Once you switch it to true, the smoothing type has 2 choices, spline or add vertices. I like using add vertices because I have more control. Down at the bottom, it allows you to choose how much you want to smooth. You can increase all the way to the right. You can decrease all the way to the left. Sometimes people just pick to smooth it a little bit, so they put that in the middle. For class, smooth it all the way to the right side, increase all the way. So we're increasing or adding vertices along those curves. Click OK. Okay, now zoom into those areas where I pointed out those sharp corners. So you'll see that it is a lot smoother. They're more curved, less sharp edges. So I want to point out one thing though. If you go to the ridge, looking at that ridge, notice how it has curved contours along the ridge as well. Okay, so you have to think to yourself, do I really want to smooth the whole surface? Is this ridge supposed to be sharp or is this ridge supposed to be curved? Because the smoothing will affect that area as well. Right, so in this case, a ridge is probably curved. So it's okay that it has these curves now. But if it was like a valley gutter, is that valley gutter sharp? Is it curved? Top of curb, is that sharp? Is it curved? So think about it before you apply that to the whole surface. Okay, so I'm going to save it. And so that brought us to the last step on creating a surface. So smoothing is optional. You don't always have to smooth your surface, but the first 3 steps, you pretty much do that every single time. CAD Masters offers online and classroom training for a variety of Autodesk software. For more information, go to www.cadmasters.com or give us a call at 925-939-1378.